Can I go? Good morning, and welcome to this very interesting and diversified session, which includes the participation of CEOs, entrepreneurs, businessmen, business angels, and institutional figures. They will bring us a rich picture of the new space economy, ranging from the industry to the startup ecosystem, with many fascinating examples of new and advanced technologies. I am Andrea Parlangeli, managing editor of the popular science magazine Focus, and since we have a very tight schedule, I will not spend other words. Rather, I would immediately start with our first guest, who is Anna Maria Candela, Vice Rector of Politecnico di Bari.
Good morning to everyone, but I have to correct you because I'm the Vice Rector of the University of Bari, not of Politecnico. And I want to apologize for my rector because he was involved in a health emergency which deals with our university, so he's involved in another meeting at the same time we are here. I want to give you the greetings of my rector, and above all, I want to point out that for my university is important to be involved in this meeting for a main reason. We accepted the challenge that was launched by the Fondazione Amaldi and its president, Maria Cristina Falvella, in order to be able to organize a different way of education. We want to involve our students in an approach to new space economy and to involve them in a different kind of studies, not for people who works in technical fields. I mean physicists or biologists or so on, but also people who studies subjects who are in usually far away from the economy. For example, people who study philosophy or human sciences. Because the challenge is to be able to put these students closer to the industries and to involve them also in projects related to new space economy. With these ideas, we are signing now an agreement between the University of Bari and the Fondazione Amaldi. And we are planning as a first step in this work together, a summer school in agri-food tech, which will be the first challenge in this new kind of education for students of the Università degli Studi di Bari. So I wish all of you have good conference and my best greetings for the organizers and all the involved speakers.
Okay, thank you, Professor Candela. I think we can have a pause.
Hello, everyone. My name is Chao. I'm from Space Engineering Development Company of China Aerospace Science and Industry Corporation. Today, it's my great pleasure to be here to share some point of view of space, economy, and industry. As we know, human beings never stop exploration of the mysterious space, using space resources to develop space industry and economy has increasingly become a new driving force for economic and social development. Today, I have three main topic sentences for my presentation. The first is, the new era of space economy has arrived. The second, space economy and industry has a broad space for development. And the third, commercial space boosts the development of space economy and industry. Now let's come to the first topic sentence. The new era of space economy has arrived. I want to first talk about the question, what is space economy and space industry, of my opinion. Space economy is a general term for the economic formats generated by all space activities and the related industries that mankind is engaged in. Exploration, development, and the use of outer space can all be included in the space industry. So the space industry can be divided into two parts, the core industry and the derivative industry. For the core industry, it can also consist of three parts, the basic industry, the application industry, and the new one, the space resource development industry. For the basic industry, we want to use this industry to construct the infrastructure of the industry, and it includes the manufacture of rockets, satellites, and the space station, and also the manufacture of ground equipment and products, and also the building of the ground infrastructure such as TT&C center and the launch site. And after we have the basic industry, the basic infrastructure, we can use those infrastructure to do the application. For example, the satellite communication, satellite navigation, satellite remote sensing, and also the space station applications and the aerospace experiments. And for the new industry area, we can use the space resource to do the agriculture, that means the space agriculture and space tourism, space mining, etc. And also, we can have the derivative industry beside the core one, which are legal, finance, insurance, consulting service, education, culture, entertainment, and other industries related to human activities in space. And we know that the space economy and industry has attracted more and more attention of the government and also the investors. Government investment budgets continue to rise. From the year 2014 to 2019, the government investment budgets of global space economy have grown from 328 billion US dollars to 415 billion US dollars, with a growth rate of over 27%. And also, the revenue of the space economy is increasing rapidly. For example, the revenue of global satellite industry has tripled from the year 2007 to the year 2019, reached 271 billion US dollars. It has been estimated that in the next 20 years, maybe the year of 2040, the totally economic value of the space economy can reach about the 1,000 billion US dollars. So that could be a very big market. As we know, the course of the exploration and development of space by human beings is similar to that of land, sea, and air. We know that the Earth is the cradle of mankind, but the human beings cannot cannot be forever living in the cradle. So the space is open for us to explore and to utilize. The year, for example, the year of 2019 saw totally over 100 launches of nearly 500 spacecrafts, which is the record high in terms of the number of launched spacecraft, signifying that the space economy and industry is about to enter a new development phase. That's my first topic sentence, and then let's come to the second one. Space economy and industry has a broad space for development. First, let me show you some my point of view of the fields of space industry to be developed. Based on the global situation, the coverage of space economy in the future will gradually expand from the Earth to the low Earth orbit and finally to the deep space. So for the space industry to be developed, we have the traditional one. That means the space transportation and also the space satellite application, which are the traditional one. And also we have the brand new one, for example, the space manufacture, space agriculture, and space mining, space tourism, and space medical care. Let's first talk about the space transportation. I mean the rocket or other launch vehicles, space transportation vehicles. With the increase in demands for commercial launching services and the development of the LEO constellation system, the profitability will keep expanding. So the space transportation market will grow very rapidly in the future. And for the space application, through the deep integration with artificial intelligence, big data, and Internet of Things, a brand new aerospace plus application industry will be built. We all know that many LEO satellite projects have been presented. For example, to build the LEO internet space constellation with the satellites of over thousands or tens of thousands satellites. So that could be a very big market for the satellite application. And for the space manufacture, the sky factories with mass production capability will come into being. We can realize the space manufacturers like the made in space and used in space. And also we can realize something made in space and finally used on Earth. Because in space we can have many advantages for the manufacture. And for the space agriculture, we know agriculture is the old traditional industry of mankind, and also it is the is the basis of human beings, because of we must rely on the agriculture for our food, etc. So space seeding and space breeding is an effective approach for food production increase and for the life support resolution of future interstellar travel. Because maybe in the future, people will not just live on Earth. Maybe some of us will move to live on Mars, and so the agriculture in other planets could become very necessary. And for the space mining, and we know that the mineral resource on Earth is limited, but many rare minerals on Earth is abundant on other planets or the asteroid. So the space mining currently, maybe it is only in its exploration phase, but once it comes into implementation phase, boundless resources for application could be opened up. So I guess the space mining will be a very profitable industry in the future. And for space tourism, maybe some people have already bought expensive tickets for commercial spaceship, but maybe it's very expensive. As the technology matures and the costs decrease in the future, taking a trip to space will become the option of more people for vacation. Maybe some days in the future, and maybe you can spend your holiday on the moon, hotel, or on Mars. So I think it will come true. And for the space medical care, because there are some special space environment, such as zero gravity, so we can use this special environment for the pharmacy. The space pharmacy may become the new and high-tech field being given top priorities. New medical resolutions are likely to happen because of the space environment can be utilized. And also, maybe if we live on Moon, on the Mars and other planets, the space medical care must be necessary for us to keep the immigrants become healthy. Keep healthy. That's the third part. Commercial space boosts the development of space industry. Commercial aerospace can provide good driving and support for the development of space industry, and provide infinite possibility for the boom of space economy, because it can create a favorable environment. It can explore, it can deeply explore and cultivate the new markets, and it can also lead the innovation in the development model. Now, CASIC, my company, has made efforts to develop commercial aerospace industry to create a new commercial model of space economy. Until now, we had made progress in commercial aerospace projects. We do the project of Hongyun and Xingyun, etc. And we also developed the launch vehicles such as Kuaizhou series. and we also do some space information application. Now, let me show you some details. By promoting construction in Hongyun and Xingyun project, we are trying to establish the space-based broadband internet and the narrowband internet of things. For example, in Hongyun project, we want to build a Leo constellation of several hundred of satellites to make people access to the internet globally for the whole world. And for Xingyun project, we want to build also a Leo satellite constellation for the many things to connect to the internet. That means the Internet of Things. Now, until now, we have launched the technical test satellite in space for both Hongyun and Xingyun project, and it all worked well. And by then, we do many technical tests and the demonstration of and the application demonstrations. And for the launch vehicle, CASIC has developed the Kuaizhou series launch vehicles. And for example, the Kuaizhou 1A solid launcher with a carrying capacity of 200 kilograms has successfully launched satellites for 9 times. And except the launch vehicle and satellite, CASIC also engaged in space information application, in satellite communication, satellite navigation, and remote sensing to bridge the digital gap of information in China and all over the world. Now let's come to the conclusion. As we all know, space is open to the whole mankind, and space, economy, and industry will bring us great value of development and utilization. And CASIC will forge ahead on the road of commercial aerospace, collaborating with partners who are dedicated to this field to make contribution to the better and faster development of space, industry, and economy. That's for my presentation. Thank you for your attention. Bye-bye.
With him later. So we can go now to the next speaker, who is Mikhail Kokorich, and is the founder and CEO of Momentous. He has a recorded speech.
Hello, my name is Mikhail Kokorich. I'm the founder and CEO of Momentous. Ever since I was a child, I always had a space dream. In an interview with a local newspaper back in 1993, when I was 16, I said, I want to study advanced propulsion technologies. I dream about the future where I can be part of space exploration and maybe even fly to Mars. At university, I studied to be a plasma physicist. In addition, as an entrepreneur, I built multiple companies, including several space companies, both in Russia and the United States. But it's only now I am finally able to make my childhood dream come true. I started Momentous in 2017 in Santa Clara, California. We are the first mover in providing space, transportation, and infrastructure services, powered by 21st century steam revolution, water plasma propulsion technology. Momentous is the first mover in providing in-space infrastructure services to the space economy. The company is focused on providing in-space transportation services, hosted payload, and in-orbit
I cannot
services.
hear the presenter.
With these business lines, we believe that Momentous will be the key enabler the industrialization and commercialization of space. Momentous has impressive progress to date. The company had developed key partnerships, including a rideshare partnership with SpaceX. We believe that the recent disruption of space launch industry will enable the next industrial revolution, and we can capitalize on this opportunity by building the premier space infrastructure and transportation services company. The market opportunity is massive, with a broader space economy projected to grow to $1.4 trillion in the next decade, and potentially significantly larger than that in the future. With the advent of rideshare missions, the number of satellites launched has increased almost tenfold over the last decade. And there will be many tens of thousands of small sat launched over the next 10 years. While the trend in the size of satellites has gone from thousands of kilograms to hundreds of kilograms or less, the lift capability of the launch vehicles is growing dramatically. Larger vehicles like SpaceX Falcon 9 are displacing smaller ones. But the future belongs to even bigger next-generation rockets, like New Glenn from Blue Origin and Starship from SpaceX, which can carry up to 30 times more payload than the current generation of launch vehicles. It takes a lot of energy to put a rocket into space and overcome Earth's gravity. Smaller rockets have to use most of their mass on structure and propellant, and not that much as a percentage is left for payloads, which makes small rockets quite expensive on a per kilogram basis. With the new larger rockets, the paradigm changes because the ratio of fuel and structure mass to payload reaches a tipping point. Rockets are getting bigger and can carry more mass, so it's become much easier to achieve lower cost per kilogram. Small rockets inherently have trouble achieving lower cost due to physics, and the result is that big rockets are 10 to 100 times cheaper per kilogram than small rockets. The chart on the right shows on a logarithmic scale that larger rockets are orders of magnitude cheaper. Before 2018, only a few dozen small sats were launched per year. Now the number has grown to several hundreds a year, but by 2024 it's projected to be more than several thousands a year. Our early adopters including launching nanosatellites and microsatellites. And we've designed our transportation solution to take advantage of these market conditions, specifically the rapid near-term growth in small sats and the big rocket that costs less than on a per kilogram basis. To cost effectively deliver our satellites, our customer satellites to specific orbit, or to deploy their satellite constellations. The same technology that we are using to develop our Earth orbit solutions will be used to build our next generation orbit transfer vehicles. They've been designed to deliver payload to other orbits such as medium Earth orbit, highly elliptical orbit, geostationary orbit, and beyond. In-space transportation services to these orbits are expected to expand the estimated total addressable market to $30 to $40 billion over the next 5 to 10 years. The flexibility and the compelling economics of Momentous hub-and-spoke space logistics have the ability to unlock countless new applications and enable a dramatic expansion of the in-space transportation market. Momentous is the first mover in building out infrastructure services in space. We partner with the launch providers like SpaceX to provide satellites with a last-mile delivery to their destination orbit. We also offer payload hosting, satellite as a service, and, in the near future, in-orbit servicing, all leveraging our groundbreaking water-based propulsion technology. Momentous is an innovative company at the forefront of space commercialization. We all about enabling the next industrial revolution, which we believe will occur off-planet. We have seen enormous commercial and government traction, and we are excited to describe our progress to date and our plans to realize both our near and long-term vision. Vigoride is a vehicle built initially for delivering nano and CubeSat within low Earth orbit. It is expected to deliver the urgent needs of early adopters, low-cost deployment of small satellites. But besides space transportation services, Vigoride is built to provide a satellite as a service in orbit services. Designed to be reusable by 2023, Vigoride is a unique and versatile vehicle that is designed to change a paradigm in low Earth orbit by its cost, propulsion and power generating capabilities, and multifunctionality. We are designing Arborite to address the broader market of larger satellites, to deliver them a wider variety of orbit, from MEO to HEO, GEO, and even lunar orbit. It will be capable of flying to any orbits in cislunar space. Favorite augment the most efficient future rockets like SpaceX Colossal Starship and Blue Origin New Glenn. Designed to be reusable from the beginning with the lowest cost per kilogram of payload, Favorite is expected to be capable of retrieving cargo in LEO and moving it to GEO, lunar orbit, or even Mars. Beyond the financial plan, Momentous has several significant long-term growth opportunities. The technology Momentous is using in developing, such as water-based plasma propulsion, low-cost solar thermal power generation with steam turbines for our larger transfer vehicles, and in-space robotic capabilities to assemble large structures are key to accessing the enormous renewable energy moonshot opportunity in space. Building solar power and data centers in space is a potentially $1.4 trillion opportunity. We are looking to harness massive amount of solar power to process massive amount of data, far beyond what is possible in current facilities on Earth. Another long-term growth opportunity is mining of resources in space. The amount of resources in space is immeasurable, making the ultimate potential of asteroid mining enormous. The expansion of the human race in the solar system will be enabled by construction materials mined from asteroids, including the rare and precious metals for industrial uses and water for propellant uses, truly the oil of the industrial revolution in space. Momentous core technologies like water-based plasma propulsion and low-cost power generation, and in the future, reusability and robotics capable of assembling large structures are ideally suited to make Momentous the leader and the primary beneficiary of this exciting future. As Carl II said, there is a deep nomadic impulse built into us by the evolutionary process. We come, after all, from hunter-gatherers, and for 99% of our tenure on Earth, we've been wanderers. The mastering of space drove our greatest innovations, and now we are on the precipice of massive change. Thank you for your time.
Can you hear me?
Yes, we can hear you.
Okay, very good. So I was starting to say, in 2020, what we observed in terms of launch to space is a very peculiar process where we saw the highest number of tons being sent to space over the past decade, almost 500 tons of spacecraft launched to space in 2020, year to date. But the number of objects almost tripled. So we reached up to now more than 1,000 satellites launched to space, meaning then that the average mass of a satellite is decreasing very significantly. So this is definitely the demonstration of the rise of small satellites becoming an integral part of the space launch domain. What are we doing in Europe, and what is AVIO doing? AVIO is working on two European rockets, two product lines, Ariane and Vega, and we are, as a company, supplier of the Ariane system with the Strap-on boosters, and the prime contractor of the Vega system, which is dedicated to the small satellites. At this moment in time, we are switching to the new generation of Ariane 6 and Vega C, and turning therefore into a new generation of rockets which will bring more capabilities and more competitiveness for Europe. So I'll show you some of what we're doing today and what we're doing for the future. This is the roadmap that we are engaged on in Europe to transform the family of our rockets to a new set of rockets in the years to come to become more and more efficient. And this process has a first milestone between next year and 2022, where we will field Vega C and Ariane 6.2 and 6.4, all of which share the same main motor for the first stage, the so-called P120. And by 2025, we will implement a further step where we will further update both Vega and Ariane 6 into new versions, which will be more and more competitive from this point of view. Introducing also liquid oxygen methane upper stage for Vega and a carbon fiber-based upper stage for Ariane 6. Now, why are we doing this? Because in Europe, we are following a strategy of economy of scale. So in the next 4 years, we will move from having two products that had essentially nothing in common to a situation where we will have three products, Vega C, Ariane 6.2 and Ariane 6.4, with this main engine in common, which will drive significantly the economy of scale, will drive the cost down, and will make access to space more and more competitive. In essence, we will move from manufacturing 15 engines on two different types of motors to a situation where we will manufacture as many as 30 engines, but only on one product platform. So this is driving a very significant industrial efficiency. Where are we on this process? Well, at a good stage. These are some of the pictures of the development of the P120 motor, which has been completed recently in October with the third and last firing test. So this main building block of the new family of European launchers is now becoming a reality, and in particular, the first stage is ready to go. And Vega C has kicked off the ground qualification review just yesterday. Most importantly, in 2020, we also achieved successfully the first firing test on ground of the upper of Vega E, the successor of Vega C, which we will field by 2025. This is the first example of an upper stage engine using methane as a propellant. So a very relevant achievement, which we demonstrated on a full-scale test, and which is projecting Europe towards a new frontier of efficiency and technology advancement. We are also building in our country, in Sardinia, as we speak, a very large test facility to make sure we can develop these engines in the future into something more and more reliable and affordable, and this test bench will allow us to test our technologies efficiently and is currently under construction. Now, among the news of 2020, very importantly, in the domain of space transportation, we are not attempting to go to space, we are also attempting to return from space, and as a result of that, just a couple of days ago, we signed with the European Space Agency and with Thales Alenia the contract for developing Space Rider, which is a very peculiar application of Vega. So it's a fully reusable vehicle, remotely piloted, that can be launched to space with Vega, can remain in orbit, conducting specific operations for 2 months, and then can return to Earth by landing on ground. This is a very, very peculiar application that will drive the future into new applications, and where Italy in particular has had a leading role also by putting together all of the different segments of the Italian industry, encompassing not only the launcher side, but also the spacecraft side, in particular with Thales Alenia, and also the ground segment with Telespazio and AVIO. So we are particularly proud of this application. And with that, I shall end maybe my presentations. I don't know whether The program is then to answer any questions or anything like that. I hope you can still hear me.
Yes, thank you. Okay, welcome back. So we can start again, and our next guest is Massimo Comparini, who is Deputy CEO of Thales Alenia Space.
Thank you. Good morning. I'm going to share my presentation. So please tell me if it is okay.
Yes.
Did you see that?
Yes.
Okay. So good morning and thank you for the invitation. In my 13 minutes, I will go through some elements about how the space infrastructures are contributing to the new space economy, to the change of the paradigm that we have in the space activity. It's a fact that we observe a kind of space democratization in the space economy. So there is a transformation in place. The space industry is going to be driven. It is driven by new services and applications. And those new applications are made possible by innovation in the access to space, in the launch industry, and of course in the satellite and manufacturing technologies. So the so-called new space industry is based on the fact that we can inject much more rapidly innovation and new development also with a lower cost. So it's a kind of sharing economy space that we see in a number of reports. It's going to be a double-digit billion industry. And of course, it implies the evolution of large players, large-scale integrator, institution, government, space agencies, let's say in this context. And you will ask why the small images on the right. At the end, of course, we were able to access the space since decades, but we see an evolution in that. Very similar to the fact that you have a 60 Cadillac, which is a red car, a Tesla, which is a red car, but of course, there is a lot that has been changed in those two pictures, and also space. It's having this kind of evolution in a number of technologies. So it's a fact that the decreased cost, increasing capabilities of our satellite and the constellations, and some breaking innovations are making the space domain more attractive, not only for scientific or for the classical domain, but also for a number of applications to enable an economy, business, new services, and also new quality of life. So this is what we regard as a kind of democratization of space. And of course, we have different domains: global connectivity, global geospatial capability, and also exploration. I will focus briefly on those. Of course, just to connect to our motto, I mean, this means that we have a space to connect, a space to secure, a space to observe, to explore, to travel, and to navigate. Really is the best fruit how the space infrastructure and space technologies are a kind of pervasive technologies today. So it's a fact that to support global connectivity and global geospatials, the evolution of the satellites, it's very important. Big satellite, small, and also very small micro satellites. If we focus just for a moment to the dimension of the space economy tightly connected to the Earth observation, which is very, very relevant point. Let me start to something which is it's more and more popular, which is we don't have a planet B. We need to sustain. We need to build up a sustainable planet, and space. It's an incredible, powerful tool to do that. We know that in Europe has been able in the past to conceive and to launch, to deploy the most important Earth observation program in the world, which is Copernicus. We have a number of Sentinels already flying, with more than one satellite for each sensor. And just in the past few months and few weeks, we're going to fix the frame for the next phase of Copernicus extensions, where, of course, I'm particularly glad that Thales Alenia Space has a very important role. We will lead 3 missions, CHIM, Roselle, 2 of them from TAS Italy and 1 from TAS France. And we will contribute with our sensors to other very 2 important, Crystal and CO2M. Each sensor has its own peculiarities, from altimeter to radar, from the capability to measure the sea temperature, the ocean temperature and temperature profile, the ice, all elements that will combine, will generate a huge amount of data to build up digital twin of the Earth and to build up and to contribute to build up a sustainable planet. What to mention also, what we did also for the meteorological satellite, because we serve all over the history of that the meteo applications with our spacecraft, with our satellites. But Earth observation is also constellation, and of course we have some of leading systems today in space and for the future. One which is more specifically on what we did in Italy is, of course, the radar constellation of Cosmos Chemed, its second generation, which is also feeding a number of export capability in the radar domain. Of course, we know, I think that all the people knows how we are leading radar technologies in the Italian part of the company and optical technologies in the French part of the company. Space to connect. We have an evolution of the very large satellite, so the so named high throughput satellite or very high throughput satellite. So tons and tons of geostationary satellite giving multi-hundreds giga, if not tera of capacity. But we have also the evolution of with the global constellations, low latency systems, and it's a fact that in the future, the space connectivity will be a layer, or the space satellites will be nodes of hybrid networks, 5G, 6Gs, and SATCOM will be fully integrated. So it's really a kind of connective layer that it's enable a lot of services that are the heart and the backbone of the new space economy. And this is true all over our systems, but there is really a contamination with digital technologies. Our systems, upstream infrastructure, are becoming more and more digital, more and more reconfigurable, hardware, and even also software-defined systems in order to give the best flexibility and to cope with the service evolution all over the life cycle of those systems. But we have, large-scale integrator. I'm honest, new space or new space company is something that I don't really like, in the sense that if there is new, means that there is an old. And typically new space is combined with the startups and new companies, which is, of course, is really a richness of the new space economy. But I don't think that the large players and large-scale integrators, so the players that did the space in the last decades, are whole space. So what I mean is that, of course, in this evolution of the space activities for infrastructure, for the space segment, for the upstream, I see more and more a partnership across the value chain, across the players, and also partners with raising a new space company. So I give you here just an example of what we did for Earth observation in the optical domain with the spaceflight industry and Blue Sky, in IoT on space, with the startups like Keynote, and also in this SSA, in the space surveillance awareness or space surveillance tracking, what at the Space Alliance level, together with Telespazio, we are doing in partnership with North Star, giving the possibility to realize a constellation for SSA from space. Just a snapshot around the Earth. Let's have a look behind that. So exploration and back to the moon is a kind of buzz. It's an hot topic in the last months. And so I like to spend a few words and few moments to connect also what is this dimension that typically is more related to the knowledge, the humankind, how we want to know where we are, our system, our solar systems, but how to connect to also to a new space paradigm. On the left, you see kind of three iconic pictures. So one is the space station, the International Space Station in this actual configuration after many years of building up. Of course, I'm particularly glad because more than 40%, about 50% of the pressurized volume has been built in Italy. We contribute with a number of elements. In the middle, you see a snapshot, a rendering of the lunar gateway. So we move with the station, we move from the fact that we have a large infrastructure where the astronauts and the men can live in the microgravity around the moon to support the new phase of the moon, which is not just come back on the planet and stay a few days, but stay, work, and explore the moon. And on the bottom, you have a rendering of a first concept of what will be a first commercial space station. So stay around the Earth and build up infrastructure that will be sustained by commercial services. And I will be back in a moment to that. So space, human habitability in microgravity, of course, already entering the dimension to support space exploration at large, and also the exploitation of commercial services. And you see in the two pictures on the center, work on the space station, work in the pressurized environment, and look into the future, work on a planet, moon first of all. So just a snapshot of the gateway. If, of course, I'm glad that all the contribution that through the continuous support of the Italian government, the Italian Space Agency, the contribution that we gave to the space station, you will see here what is today the plan to contribute to the gateway through ESA, the European Space Agency, having prime contractorship of module like the International Habitat that we lead with Thales Alenia Space Italia. ESPRIT we lead with Thales Alenia Space France and qualified contribution from the Italian part. But also what is a part of the bilateral agreement and discussion between the US administration, the Italian government, NASA and ASI. So the human landing systems and the contribution to the HALO, to the Habitat Logistic Outpost and to the Orion vehicle. So basically we have two elements that is also part of this very important bilateral that will give in the future years the basic infrastructure to develop a kind of lunar economy, which is the human landing system. So basically the vehicle that will be back and forward the gateway and the moon. And we are one of the three teams competing for the development of that, and we are the only Europeans teaming up with Dynetics. And starting from all these legacy and experience on the pressurized modules, think about the first habitat on the lunar surface, of course, with all the protection to make possible the life for the astronauts, even in the pressurized module, but protected by radiation and micromicrowaves. And of course, this is the combination, and this is the result of a large involvement of a filiere of small medium enterprises, and this is basically the domain where we're going to embrace all those technologies: thermomechanics, of course, subsystem for avionics, energy, electronics, robotics, AI, artificial intelligence, of course, advanced software architecture, and also the habitability and design and the ergonomicity to make more more comfortable to stay for a longer period in those kind of environments. And just a snapshot on the commercial environment, we are partnering with the company Axiom, and the goal is to provide the first element, the first pressurized modules to sustain a commercial space station. So a place where, through an easy access, ownership of the mission, and of course the right element to have productivity and comfort there, based on a certain cost, we can project a revenue profile where this is a sustainable. And of course, as you can imagine, sustainable through services from pharmaceutical industry, new materials, and things like that. All the domain interest to develop new applications where in microgravity they can do job that is not, it's more easy to do, to make new things and new discoveries than with the gravity. Of course, in order to do that, we need to have a full supply chain, value chain, and this is just to snapshot the element of the control center that we have in combination with the Italian Space Agency. Altec is a JV between CAS and the Italian Space Agency that is the place where we control all the operations around the Earth on the space station, but also in the planetary journey. So we know that the Moon is a kind of lab, and we don't. It's not a limit, of course. It's a starting point, and you see here on the right, I think quite an iconic image of what is going to be on Mars, and really how the intimacy between what we have designed and what we are going to explore is machine and the man. And by the way, I really think that also through artificial intelligence and robotic, we will have the cooperative approach between the astronauts and the machines that will help to explore and to work on the Moon. It's been already mentioned by Giulio Ranzo before me. We just recently signed together with AVIO the contract for the development of the Space Rider, which is a reusable vehicle able to go to access to space, and it's an unmanned spacecraft that can transport payload into low Earth orbit and safely re-enter in the Earth on the Earth surface. Again, it's another domain where I think space economy in the coming years will give the opportunity to explore new services and new applications. This is my very last slide. There is also a combination technologies-wise, in the sense that, of course, what we see, the capability to design those complex infrastructure from small sat to big sat in Earth observation, in telecom, in communications, tons of hardware to explore our systems, so to live outside the Earth. Today, the use of digital technologies, the evolution of digital technology is fundamental also for us, also for the manufacturing industry. And really, we see more and more digital on space, but we see also more and more digital in the design phase, in the testing phase, in the verification phases, and at the end in our capability to short the life cycle of our design, and our projects. So really, I think it was just a brief snapshot, a panorama of all the elements why space is really the heart of a new economy paradigm that we call new space economy, and is also fundamental for our life on the Earth. And I close with our motto, which is Space for Life. Thank you.
Thank you, Mr. for this very nice, very clear presentation. You were just in time, so please disconnect. And then we are ready to go to the next speaker, who is Chiara Pertosa, President of Sitael, a leader company in the aerospace industry, providing next-generation satellites. She is also director of Angel Company and member of the board of directors of Mermec. Please, Mr. Comparini, disconnect, because we can still see you. We need to jump to the next speaker. Thank you.
Thank you.
Okay, the floor is yours.
Thank you. So, Sitael is the largest and privately owned company in Italy operating in the space sector. Our group invested more than 10 years for research and development to let Sitael become a company and not a research center or a startup with good ideas. Let's talk about our product. We are specialized in components and avionic units. We have electronic background and history, but we are also specialized in the electric propulsion, as Sitael systems are based on all-effect propulsions, unique competence in Italy and among the most advanced systems in the world. We were born like subsystem and propulsion unit supplier, and we become platform supplier. Let's go to the next slides. This also thanks to M&A operation that we became in the last year platform integrator. Seeing these slides, we see that the 2020 are predicted to be the decade of small satellites with an annual average of 1,000 small sats to be launched. By comparison, 2019 had the highest number of small sats to date, with 385 small sats launched. From 2020 to 2029, the small sat market value is projected to reach 51 billion, of which 33 billion for manufacturing and 18 billion for launch. This is more than 4 times the market size of the previous decade. Our main product, Platinum, is a microsatellite of 200 kilos, more or less, with electric propulsion, which is modular, equipped with a wide range of payloads. Platinum is a profitable solution for the purpose of Earth observation, and it could be the Italian answer to the new space economy. With our partners, Leonardo, Thales, and Airbus, we signed a long-term agreement to offer Platinum to European and international customers. This long-term agreement is for Italian Space Agency a guarantee. Till now, Sitael has grown with our own resources. This week, as we can see from these images, this picture, we started the building of a new facility where we are going to integrate Platinum, and where it will be possible to integrate a larger number of Platinum. Being a modular solution, it's perfect for constellation purpose. Till now, Platinum is equipped with all effect electric motors, 100 watts. We have other sites of motors. We can see here 400 watts, but we are now designing and ready to produce a motors which will be 5 kilowatts, and it will be the Italgovsatcom motor, with other follow-up, like could be, for example, the SICRO. This is a recap slide of our group. We come from, let's say, railway sector. It's because of this background that we participated to EcoTrain program of European Space Agency. This EcoTrain program connects all the skills and competencies of our group with this COVID train. It will be not only a demonstrator, as it was supposed at the beginning, but it will be a real train with intensive care stations, ready and homologated. This is the most important things, to circulate in Italy. The competitive advantage and the innovation consist of special satellite communication antennas able to transfer big quantity of data relating to patient conditions. Thank you for the attention.
Okay, President Pertosa, thank you for your presentation. Well, maybe I would like to ask you, from your point of view, what do you see as an interesting example of success stories in the, let's say, startup ecosystem in Italy?
There are many startups in Italy in space. What I think about startup in space is that in space you need to invest at here 5 years before. So private equity funds or banks or institutions that would like to participate to investment and at startups to grow, to build what we always call as new space economy. It will take at least 5 years. So it's we need to consider this time to have a return of investment.
Okay, thank you and good luck. And I think that we can have now a pause before we go to the next speaker. Welcome back. We can go on with the following speaker, who is Matteo Cascinari. Welcome. Who is general partner of PrimoSpace, the first Italian fund dedicated to startups in the space economy.
Okay, thank you. Well, let's start with the good news. I don't have slides, so you can just follow me, and this is to prevent the overload of slides for the audience. Thank you very much for inviting us, and it's an occasion for us to explain what we do and how we do it. First of all, let me share how we see the space as an industry. Most of the people that participated to this project, me, Gianluca Dettori, Giorgio Minola, and Raffaele Mauro, me, Giorgio, and Raffaele are the investment team, participated 25-30 years ago, about 25-30 years ago, at the internet revolution that happened. The first commercial launch in Italy was in the summer of 1995, 25 years ago exactly. What happened basically? Happened that a public closed infrastructure like the internet was, suddenly, that was used only by governments, military people, suddenly opened to the private exploitation and the commercial exploitation. And everybody of us could see what happened in the last 25-30 years. A huge new economy, the new economy was called at those times, arose. Google, Amazon, Microsoft, Apple are all big giant now. that 25 or 30 years ago didn't even exist. And now are huge companies dominating the market scene, the economic scene, and the everyday life of everybody of us. So this is how we see space. In a certain way, we see a lot of similarities. An industry that was basically closed to the private exploitation because of the costs. So basically, the access to space was granted only to governments or huge companies that do have a great budget to go to space. That suddenly opens, and now the access to space is guaranteed also for startups and low-budget companies. And we think that this can bring, I don't know if the same impact of that revolution, but we see a lot of similarities. So we have in front of us, we think, at least 10, 20 years of a future of growth, of disruption and creativity. But let's get back to PrimoSpace and how it works. PrimoSpace is a normal, let's say, venture capital fund investing in space. This is our specificity. We just invest in space, but with the notion of space that I told you. So we consider space an industry, but also an infrastructure that enables a lot of other businesses. So in terms of, if we look at the space industry, we can invest upstream, downstream. We can invest in space hardware, in software, in rockets, in launch services, satellites, geolocation data, Earth observation, whatever it is. We don't have a preset allocation stated, so we don't have an allocation. Let's say 40% upstream, 60% downstream. We can go where the opportunities are or where we see there are opportunities. So we're very flexible and agile. We can act as we like. But we also invest again in what we call space-related business, like precision farming, insurance solutions, space pharma, and so on. We made in July our first closing with approximately 60 million, 60. We are still in fundraising, so we are targeting a final closing somewhere in between 80 million and 100 million. And this can lead us to make 2025 investment in a 10-year time span. But actually, the investment period is 5 years. So we must invest all of that money in 5 years. Geographically, we invest 80% in Italy. I think this is a great, huge occasion for Italian startups. And 20% abroad, where abroad, as per our fund rules, is limited to the US, the United Union, Israel, UK, and Switzerland. And how much do we invest? Basically, we invest from 0 to 5 million. Ideally, we divide this gap in two areas. The first one goes from 0 to 1 million. That finance what we call the early stage phase of startups. The average ticket is 500,000, 1 million. And then the second area that for companies, startups that are in the scale-up phase of their life. And here the investment goes from 1 million to 5 million, let's say, as an average 2-3 million approximately. What we are looking for, as I told you, in terms of industry, we are very flexible, but we, beside the companies and startups with great potential, with great technologies, we look for great teams, which is very important for a venture capital firm because startups are not companies settled down, located with a lot of structure. They're companies that walks through the legs of the founders. So we look for great teams, passionate people, dedicated, motivated. We always say that the team must have a 100% time commitment, financial commitment, and emotional commitment. So it's very important for us to evaluate the team, the people that are the founders that are working on the startups. Me, Giorgio, and Raffaele, just a few words about our background. We are not tech people. We don't have a background, a technological background in this industry. We are finance guys, so we can understand. We analyze the opportunities on a business side perspective, financial perspective. We can understand the market and the dynamics of the industries. And as far as technology is concerned, we have a strategic partnership with Fondazione Maldi, which is the owner of this field. So, and they through a two-steps validation process. The first one is the light validation. And then there's, if we decide to go on with opportunities and actually to invest and go to the due diligence phase, there's a second validation and second analysis that goes deeper in the analysis and give us their view of the technology. We have recently announced our first investment. We are very happy about that. The investment was a company startup based in Torino called Icospace. They make software, basically it's a software company, big tech software company. They make software for artificial intelligence for autonomous mission. Very smart guys with ambitious plans, and I hope and I think we can announce a second investment before the end of the year with another company. I can tell you the name right now, but it's another interesting company, a little bit bigger, a little bit bigger and more mature, in a very interesting market. And I think again that we can announce it within some days, not more than some days. Just a final call to action. There are some startups listening in the audience. If you have any plan, if you're ambitious, if you think you have a great idea and a great plan, please send it to ignition@primomigliosgr.it. We are there waiting for your plans. That's it. Thank you.
Okay. Thank you, Mr. Cascinari, for this interesting presentation. Since we have some minutes, maybe I have a question for you. I would be curious to know, from your point of view, you said you have 80% of focused on Italy. I would like to know whether this is only because for geographical reasons you are based in Italy and so this is the market you know better, or if it is because you think that the Italian ecosystem has some strategical strengths that are important in the global scene.
Well, both reasons are the reasons that leads us to invest 80% of the commitment in Italy. Yes, because Italy is very strong, is prestigious, has a huge history. We have, as everybody knows in the audience, the whole industry chain covered. So I think that Italy must be considered very well. And obviously we are Italian in Italy, so our connection, our network is in Italy. If the market goes in the same direction and where we think it is going, I mean, if it will grow, as we said, probably the next fund will be an European fund or a fund with a broader, a greater geographic focus, and maybe with teams in other countries. But well, let's say let's concentrate and focus on our fund, and let's try to give a great return to our investors.
Okay, which are the sectors that you think are more interesting at this stage?
Well, actually, as I mentioned before, we don't have a specific focus. We are very open, so we are looking very interested. Well, we thought at the beginning that we would have meet more opportunities in the downstream area. While we are seeing now, I don't know if it's something, I mean, it's a case or something structural. We are seeing a lot of interesting things in the upstream area. which is good for us because the upstream needs more time. So it's better for us to invest at the beginning of our fund because we have 10 years in front of us. So the upstream is good to invest in the upstream right now, and less things in downstream. But again, I don't know if this is something that is going to remain the same in the next 2 or 3 years or will change.
Okay, thank you very much.
Thank you, and thank you to the audience.
We can have a pause and then see you again in a few minutes.
Okay.
Okay, welcome back. We try to make a connection to the next speaker. The next speaker is Carlo Cavazzoni, who is head...
Yes, I'm here.
Can you hear me? Okay.
Yes.
Carlo Cavazzoni, who is head of computational research and development at Leonardo. The floor is yours.
Okay, I will try to share a few slides just to let me try. We can see. Well, let me check the right one, which is this one. Well, this is this is supposed to be the last one, but just to a very quick and personal, let's say. I'm not, let's say, an expert from space economy. I'm an expert on high-performance supercomputing technology. But just to a little anecdote from my anecdotic item about my career. In 1999, I worked on explanation of the data from Space Voyager, from a Voyager spacecraft, in particular. Data coming from Uranus and Neptune, and actually using supercomputer, we were able to explain the magnetic field of Uranus and Neptune. That was, let's say, a little bit weird as it was collected by the Voyager spacecraft. Just let's say a little introduction, and to say also that supercomputer and space, I think, are a perfect match. In fact, I think. Even if I'm not an expert, but so supercomputer have for a long time been designed and developed to support the space mission. So why not this can continue in the future? And our answer is yes. This I think it will be my first message. But then let's start from the main. I don't know. You can see the picture.
Yes, it's fine.
Okay, but probably not in anyway. I'm one of the director of the Leonardo Labs, and in particular, I'm in charge of the high-performance computing, big data, and artificial intelligence lab. Leonardo Labs cover many subjects. One of these are space tech, and one of the things. We are going to support the space technology with supercomputer is for, let's say, processing data and running simulation and developing a special purpose artificial intelligence algorithm specifically designed for working and dealing with data coming from space. This is a picture of the new supercomputer we have deployed in the Leonardo lab, which is called the Da Vinci 1. Okay, and the supercomputer is number 89 in the top 500, so the list of the most powerful supercomputer in the world. So it's really, let's say, a significant machine for a company like Leonardo. And if you take the subcategory of let's say, supercomputer for space exploration, let's say this one is just behind, let's say, the NASA supercomputer and the JAXA supercomputer. So it's really a powerful machine which can be used to support the Leonardo activity in many of the sector we are involved, but also in the people working in space economy or space-related products and services. Just a few more words. There is not only the supercomputer in the Leonardo lab. We will have also 100 of researchers and a PhD student working with us in order to develop the high-performance supercomputing technology and or big data technology, because a supercomputer without software is useless. If you want a supercomputer, it's becoming really useful and powerful when you develop the software on it. Obviously, the power is required to enable faster and more powerful and new solution, but we definitely need an effort in order to develop new software. And if you want, here we will have all the three components to really change the rate in which the company can provide services and technology, because we will have computational power, storage power, if you want storage space, and the people developing new artificial intelligence and simulation solution above the lab. To say the truth, we are also running laboratory and people in collaboration and together with the laboratory, the development laboratory of the different division, or let's say company in which Leonardo is involved, like Telespazio or EGEOS. So we are closely talking together in order to, let's say, check what is the support that we can provide to their activity and to the researcher for developing the new service and solution. If you want another way to see the supercomputer or the laboratory technology is to analyze the key enabling technology we will support. So from the point of view of hardware, in our radar there is obviously HPC, cloud, which are sort of, and I will explain in a minute, are going to converge. Then the other two are IoT and edge, and probably edge is also interesting for space economy, because one can see, let's say, a spacecraft like an edge device, because when you fly remote from the Earth, you need to bring with you the computational capacity. Otherwise, you will not be able to contact back the Earth to have an urgent request in services. And then from the software point of view, in the lab we will develop capability in order to run simulation, artificial intelligence and big data analytics, which are the two, if you want, the two buzzwords of the moment, and digital twin. But beside artificial intelligence and buzzword, what supercomputers are really good at is to accelerate and empower the knowledge you have about a system or a situation. Okay, so in a sense, today is artificial intelligence, tomorrow cognitive computer, and as we go, the computer will be more and more able to replicate cognitive capability of humans. Okay, starting from basic arithmetic, now we are at artificial intelligence. So supercomputer with ad hoc software can replicate, let's say, one of the capability of humans, which is recognizing objects in images, just to make an example, or understanding the syntax of let's say a written sentence. Okay, so now these are limited and vertical capability each algorithm of artificial intelligence is able to do, and it can be useful for already useful for space economy. But tomorrow, the idea is to have more advanced cognitive capabilities, so integrate multiple sources of information, and let's say becoming more and more capable of high-level functionality that can imitate human brain functionality. And this will be, I think, important, especially if you would like to target space mission far from the Earth. So in fact, one of the lab we will host in Genoa, it will be the space robotics space lab, and where we are going to conceptualize and develop robotic solution for the exploration in space. But how the supercomputer can be used? Well, today supercomputers are more and more, let's say, converging toward a cloud paradigm. So obviously, our supercomputer will be able to be used sort of in a traditional way, so connecting using a terminal and let's say running processes as it has been done since the beginning of the supercomputing era. But more and more, and if you check today on the offering of Amazon, Google, and Microsoft, you can see that all of them are starting to offer HPC on the cloud. In fact, the cloud started many years ago as a way of consolidating data from the remote to central hubs, and provide service on this data, mainly to store the data from mobile phone and or other peripherals. But today, now the situation is evolved that together with the data, they can provide also computational capacity in order to analyze the data, first of all, but then especially with artificial intelligence, to develop and run artificial intelligence or simulation framework above the data. So at the same time, HPC is moving toward more and more data-driven setups, and so today the resources can be accessed even if they are a supercomputer using cloud-like paradigm. So from the edge, from the internet, you can move and store data to the cloud through specific virtualization service. And this is what we are also intend to do with our own supercomputer that will be accessible by our engineers, both using terminal, but also using a virtualized service. Then the last slide. So all this, as already I've said, supercomputer is a tool to crunch two things essentially: numerical models and data. So out of these two ingredients, using HPC facility or cloud facility, which I said are to see almost now to express the same infrastructure. You can run a simulation, and well, today simulation, one may think also digital twin or artificial intelligence, especially the training part. And out of these two main pillars, you can obtain information or and prediction. So in other way, knowledge. So we, as Leonardo, we intend also to use this new facility to support all our businesses related to the space economy. And I think, as I said at the beginning, supercomputing and space economy have born together many years ago, and I think they are a perfect match. Thank you.
Okay, Mr. Pasquali, thank you very much for your presentation.
Cavazzoni.
If you can answer very quickly in 1 minute time, I would like to ask you. Hello?
Yes.
Oh, you're still there. Okay. I would like to ask you if you can give a few examples practical examples of where you can apply this computation.
So as I said, this was my little research I've done related to space data. At that time, when I ran the simulation I presented at the beginning, we analyzed the data coming from the Voyager spacecraft. They collected data from the magnetic field of Uranus and Neptune. And this magnetic field were really weird because the source of the magnetic field was inside the ocean, not in the middle of the planet. So an explanation was sought in order to check what was conducting in the ocean. So we ran accurate molecular simulation of water and to discover what happened to the water at that planetary condition. So this is an example of my personal curriculum. But today, what I think is most important and what is the really killer app is data analytics. So we can with this supercomputer crunch an enormous amount of images, high resolution images and signals, and use artificial intelligence to understand and discover feature in this image. I don't know if then in the other presentation there will be any use cases about that, but I think this is what our researchers, together with the colleagues in Telespazio and Geos, are going to do. So develop artificial intelligence algorithm to automatically process thousands of images all together at the same time. So this is, I think, is one of the killer app in the near future. Then I think a supercomputer will be required for the let's say to develop, as I said, let's say cognitive capability to imitate more and more human brain and to let's say have autonomous space vehicle.
Okay, thank you very much again. Good afternoon, and I think we are ready for the next speaker, which is in just 1 minute time, so probably is already connected.
Yes, good afternoon.
Good afternoon. Good afternoon. So our next speaker is Luigi Pasquali, who is the CEO of Telespazio.
Yes, I think, I hope that you also see me. I've switched on also the video. So very well, thank you for inviting me, and then good afternoon, everyone. I want to give some contribution to the debate of today on about the new space economy. From the angle of a service provider like Telespazio. As you know, we are focusing on operation of satellite systems, maintenance and operating conditions of satellite systems, development of ground segments, but also as a service provider, we are focusing on a number of services basically based on satellite communications, geoinformation, navigation, and other space technologies. So, new space economy, from our point of view, from our angle, is basically showing three main trends. The first one is that clearly the space is very much oriented today towards the use of technology for the benefit of citizens. New space economy is a frontier that is creating conditions for significant development of space services and applications. Is basically in the logic, in the concept of economy. It is space services and applications are enabling factors for economical development. The second trend that is very important for us, for our activity, for our plan, for our vision, is the digitalization, which is creating a situation, a specific situation where space is no longer a self-referring industry. It is clearly turned into a fully integrated layers of a number of networks and platforms which are affecting our everyday life. And by the way, I mentioned the digitalization, and digitalization goes towards the space value chain in all the direction, upstream on the satellite, midstream and downstream, ground segment and service and application. So first, as I said, space economy as creating the mood for service and applications for citizens, for institutions, for enterprises. Digitalization taking space no longer a self-referring industry. And third, competition, which is growing. Clearly, it is evident that the entry barriers are lowering, both technological and financial. There are a number of players, a number of actors which were not traditionally space-based or space-devoted and focused, which are opening their contribution into the space arena. So, which is also an important trend for us. So, all those things for us, I think that are opportunities, because for sure the market is growing. The possibility to develop new services and applications is also growing. So that is why we are focusing as a service provider to a set of value-added services which are based on the combination of the telecommunication, geoinformation, and navigation, but also crossing transversal technologies, which are basically the artificial intelligence and cybersecurity. These two technologies are in a way transversal in all our applications, because security and the benefits coming from artificial intelligence are clearly the state of art and what basically is necessary to grow. Of course, it is also a matter of models, business models. So, for instance, we are opening the concept of ground as a service. I mean, not everyone today is capable to maintain the logic of having dedicated infrastructure for space systems or very small constellations, micro satellites, and so on. So, Telespazio is opening new models of offering services, basically also towards these new ventures. So I've mentioned the importance of so-called the next generation technologies. So I want to quickly list which are, in my view, the most important, which I'm expecting or are already a sort of breakthrough in this new space economy environment. The first one that I want to mention is the in-orbit servicing. Indeed, space is an operational domain, and there are today a broad range of solutions for a satellite operator, which are based on the concept of rendezvous and proximity operations technique, and there is of course open a number of services and specifically demand, which we are preparing to answer with some offer: refueling, life extension, inspection, active debris removal, and so on. The second that I want to mention, which is related with this one, always remembering that space is an operational domain, it's a space surveillance and tracking, space domain awareness, as we like to call it today. Of course, Telespazio today, having the hands on operating third-party assets, and we are obliged already to implement collision avoidance maneuvers to protect orbiting assets from space debris. But this is, a starting point. And we need also to develop additional capability to improve the space domain awareness. And as you know, we have invested in a Canadian startup, which is Northstar, which has a very important project in the hands, ambitious, but I think that can play a disruptive role, referring to the possibility to build up a constellation which may explore and take under control space from space. And we are relying on this solution. Another technology is quantum technology. It is definitely a very promising evolution for secure digital communications, and as you know, is already in the roadmap of ESA and the European Commission, with the aim of guaranteeing the basic infrastructure and the management for communication and cybersecurity. This is a technology also on which we are focusing, and we are expecting that in the NSE environment that will play a significant role. We have mentioned artificial intelligence. Artificial intelligence, we heard from my colleague Carlo Cavazzoni when you have asked him which is the main application, or one of the most important applications that you deem appropriate with these technologies, high performance computing, for to realize also artificial intelligence algorithms. Is answered referring to the quantity of images that we may process and on which we may apply data analytics first, and then of course artificial intelligence. This is on our path. Geoinformation applications referring on a number of vertical markets are based on these technologies and these innovation. Also thanks to our thanks to Leonardo and the evolution of innovation that Leonardo is pushing, and in particular we will drive at Telespazio among the Leonardo labs where the innovation will be developed. One specific Leonardo lab will be dedicated to space, and we will drive it as a part of the Leonardo group. But it is to afford the new space economy environment, which I was referring at the beginning of my speech. We are not also looking to technology. There is also a matter of a new service model, a new possibility to offer something which is capable to respond to the increasing and evolving demand. I think that I may mention in the very short time that I have two aspects which are for me very important. Data fusion. Data fusion is definitely one of the most important. Inside by the way, it is based again on the digital capabilities. Inside the geoinformation, data fusion means that we are capable to extract information by putting it together data, images coming from a number of different technologies, sensors on board of satellites, optical, radar, hyperspectral, different frequency bands, and so on. This is a very powerful service model, and we see that this is enriching a lot of our applications. The second one is the use of drones. The drones is a very complementary technology and techniques which is capable to reinforce and enrich the applications of geoinformation, different verticals. Let's think to the emergencies, to the monitoring of critical infrastructure, to the agriculture, but also to transportation. Drones may also help in transporting material from logistics centers to local capillary hubs, and these recall satellite technology for satellite communication and guidance of these systems. So these are the evolution of the business model. I have maybe a few minutes still, so to close and go to land my speech, I think that I need to mention that this environment that I've described, unfortunately, in 2020 has been it happened into a COVID-19 year, which is something that has shown some resilience of our sector, but of course some impact. Less satellites have been launched because for a number of months we have had the launch pads which have been closed. but also in some services we have measured the reduction of usage and traffic, like maritime, like in-flight connectivity. But on the other way around, we have also found that the satellite systems are capable to support the management of the emergence coming from the pandemic, particularly for teleworking, video conferences, and also geoinformation techniques to monitor and to support the emergency. So COVID is passing through, NSA is passing through the COVID-19 period. We hope, of course, that 2021 will be the year of recovery, but at the end, we have measured some resilience. Just the last concept that I want to give you is referring to the investment. The new space economy allows investment to a large base of private investors, including enterprises like Telespazio, and then of course we are catching this opportunity because as it is, as we said, an enabling factor of the economy development, it is also an enabling factor to sustain the return on investment in several applications, and we are following this. Of course, investments are also very much important, and we are seeing, particularly in Italy, a great priority of our government in investing in space. Thank for that, but we perfectly understand that there are new frontiers which are very much focused by institutions, like, for instance, explorations, like the new programs which will see our industry, our country, also working in the exploration of the moon and maybe in the future of Mars and so on. So great opportunities. 2021 will be a new year also where maybe the COVID-19 progressively will reduce its effects. And new space economy is a great opportunity for everyone, for Telespazio, which will celebrate the 60th anniversary in 2021. So we have our roots very deep, but what is important for us is the future. And we are preparing, as in a few minutes I've tried to explain exactly our role in a sustainable future in the new space economy. Thank you very much.
Thank you, Luigi, Pasquali, for this very complete presentation. Now we can have a pause again, and we start again at 14:08 with the speaker. Please disconnect now. Ready?
Ready here, yeah.
Okay, good afternoon. Welcome. We have now a very special guest in direct connection with the United States. We have Kevin O'Connell, who is the director of the Office of Space Commerce from the US Department of Commerce. Mr. O'Connell, the floor is yours.
Thank you very much, and good afternoon, everyone. It's still early in the day here in the United States, but I'm delighted to be able to join you to talk about the space economy from the U.S. perspective. Let me start by thanking Dr. Roberto Battinson and Dave Amilkumar from the Italian Space Agency, as well as our International Trade Administration here at the Department of Commerce for inviting me to participate with you today. Very excited to be here to talk about this. As mentioned, I'm the director of the Office of Space Commerce, and sometimes people congratulate me and say, boy, that's an exciting new office, isn't it? When in fact, it's an office that was created over 30 years ago. I see Jeff Manber is going to follow me on the schedule, and he was part of the early days of the Office of Space Commerce when there was a vision for space commercialization and how that would go. One of the themes that we use regularly in the Office of Space Commerce is the need to leverage the entire department on behalf of the commercial space industry. And so we'll talk more about that in a little bit. I'm very excited to talk about the space economy today. It's been an exciting week in the United States. We're just back from the 8th National Space Council meeting down at the Kennedy Space Center in Florida. And among other discussions about space exploration and the security aspects of space, obviously the Vice President announced the new national space policy that will have an enduring effect on how we encourage the growth of space and space commerce, not just in the United States, but also with our partners. And specifically, the national space policy recognizes that a robust commercial space sector is important to our economic and national security. And so it commits the United States to fostering the growth of that space economy, as we'll talk about it today. It also reaffirms the commitment to many of the prior discussions we've had about space policy. For example, the regulatory reform, making sure there's a light touch regulatory reform, securing the IT infrastructure associated with space, as well as the discussions about space safety and sustainability. And we'll talk more about that in just a little bit. You might imagine that at the Department of Commerce, we're very excited about the space economy. But that's not just enthusiasm. It's really all about understanding the critical elements that go into building the space economy, but also the economic output of the space economy. And so I'll touch on those themes in my few minutes of remarks today. How do we think about those things? How are they changing, et cetera, et cetera, et cetera? What's most exciting is that many of the capabilities that we were just talking about 2 years ago are actually coming into the market in either demonstration or in operational reality today. Again, Jeff will probably talk about some of these things himself because he's in the business, actually. He has some exciting developments of his own to talk about on this. And so things are moving very, very quickly. The space economy is accelerating in this sense. Now, you all know the numbers. The economy is estimated to be roughly $420 billion a year space economy, and that's on the input side, if you will. And 80% of that is commercial, and that percentage is growing and bound to continue to grow. Government activities are still very important, but commercial activities are the lion's share of activities in space, and that's very, very important. I'll come back to the numbers in a bit, but obviously that balance of government and commercial activities is prompting us to think about space in a very different way. Think about things like partnerships, think about the relationship to security, to think about the nature of competition. So it's very important, the thinking that's going on in parallel to these activities. Let me generalize for a minute and say that in the United States, we're seeing 3 clusters of space activities. The first is what I'll call the disruptors, the people that are coming into the market with new ways of disrupting what are existing commercial space markets. And so you will know them as communications, remote sensing, to some extent weather. And these are people that think that either because of technology or a different business model or a different approach, that they can actually change the landscape of those particular space functions. The second is the group of what I'll call innovators, people who are trying to create wholly new capabilities in space, and the extent to which they have a new idea, a new technology to bring to bear. The third is an area, and I think this is a relatively recent occurrence, is a group of companies that are thinking explicitly about infrastructure in space. And infrastructure is everything from deep space communications done as a commercial service to the folks who are thinking about training, housing, and other things for the next wave of space tourists that are going to go to space and then live there sustainably, obviously under the SPD-1 mandate to go back to the moon sustainably as a pathway to Mars and beyond. Of course, the other way to look at this economically is to look at the impact. In the United States alone, space is thought to have over a $5 trillion impact on the economy. And that's on everything from weather to entertainment to finance to the internet to navigation and all of the other functions that we all leverage many, many times a day, many times without even thinking about it. And so how do we think about that economic output? And I think everybody on this call will recognize that we have to still do a better job of socializing the impact of space on our daily lives here on Earth. And I know that's something that we're all very interested in. Obviously, it's been a challenging year for not just the space economy, but for everybody. And we were delighted to see the space industry in the United States remain resilient in the face of the COVID pandemic, the early days of the COVID pandemic, especially. I think there were a number of reasons for that. There were important administration programs to help with economic recovery and stimulus, but there also was a connectivity that was in place between the U.S. commercial space industry that helped us and the government understand the unique impacts of COVID on the space industry, proposals for recovery, and things like that. We're seeing at this point the Q2 numbers in the finance community were down, understandably, but we saw the Q3 financial numbers roaring back, and some analysts are saying that the industry is on track for the best investment year ever in this area. We wouldn't have thought it that way if we'd asked the question 6 months ago. Now, Europe is also experiencing tremendous progress in space, and that's evidenced just by the number of people that are estimated to be on this call, but it's also through other connections that we have from the Office of Space Commerce. For example, I'll just give a few short examples. I was in Luxembourg a few months ago to view some of the more innovative companies in Luxembourg, and those are large companies, medium-sized companies, and small companies. The Department of Commerce also signed, or my boss, Secretary Ross, signed an agreement with the head of CNES, Jean-Yves Le Gall, last year on SSA cooperation. We're doing a lot of work with the OECD on space economy statistics, as I'll talk about again in a few minutes. Finally, we're very much partnered with Europeans, both the European Space Surveillance and Tracking Consortium, but also ESA, on ideas related to space safety and sustainability. So again, I'll come back to that. So what's actually happening here? What we're really witnessing is a transformation of the space economy based on the application of commercial efficiencies and business practices to traditional space acquisition models. And again, I think this community will understand immediately some of the trends that we're seeing. First is the increased availability and lower cost of launch. Second, for example, is the small sat revolution and the extent to which it allows for increased experimentation in new space applications. We're seeing a lot of benefit in the space industry from what I'll call adjacent technology applications. So, for example, the dramatic increase in throughput of communication satellites, or the increased diversity and volume of remote sensing capabilities, new kinds of phenomena that are being explored. And then the whole application of artificial intelligence and machine learning to help us make sense of the crush of data that is coming back from space. These are all critical parts of this. But I do also have to give credit to another factor, which is that in the United States, for sure, the government has become a much better partner in space. And so we can look to examples of NASA reaching out for lander capabilities, or the regolith requests that were made a couple of weeks ago, the program to ask for companies to participate in securing regolith on the moon, or other such commercial activities that are done in the Department of Defense, the pitch days that you've probably heard about. We just held the first international pitch day in the United States. So what kinds of things are we seeing? And I'll just rattle them off quickly. I think the community here is familiar. We're seeing developments coming into the market very, very quickly in areas like satellite servicing, space refueling, space tugs, on-orbit manufacturing. So again, we're already witnessing the impact of 3D printing on Earth that relates to space, but also 3D printing that will take place in space. Very exciting developments there. Seeing developments in resource extraction, mapping, and the technology to actually do the extraction. We're seeing the emergence of a private astronaut mission that could go up as early as late 2021. We're seeing work in active debris removal and other places. In addition to things that are in the space community, we're also seeing innovations in the space finance community. There's an absolutely critical aspect of private sector finance and insurance that is going into the speed associated with this. And so we're seeing both venture capital, but other mechanisms being considered for financing a longer duration of the space industry. So what have we been doing? Of course, in the United States, I mentioned the new national space policy. We have used a very intense whole of government effort for the past 4 years to make progress on regulatory reform, space safety and sustainability, the cyber links to space systems, and others. And again, those are all codified in the new national space policy. You've seen the president's executive orders on things ranging from resource extraction and the international support for that to the resilience of position, navigation, and timing, a critical piece of the infrastructure. And so these are all pieces of things that we're doing. Now, when I mentioned at the beginning that we're looking at commerce at some of the inputs, I'd like to give you a sense of what we see as critical to reaching the $1 trillion space economy as fast as we possibly can. The first is continued entrepreneurship. In the United States, especially, we enjoy a very wide and diverse approach to entrepreneurship in the space industry, and we expect that's going to continue. Space continues to inspire us. Secondly, robust finance and insurance backing from the private sector that will complement government investment in space. We see that as a critical, essential piece. Continued implementation of regulatory reform. We're at an interesting point in time when we have both mature space powers and emerging space powers, and how will we think about regulation in that context, both in national context, but also in an international context as well. There's a need for innovation in new technology areas, such as safe nuclear propulsion, nuclear power, cybersecurity, as I mentioned, space medicine, just to name a very, very few. Jeff may talk about innovations in food and space. I know that's a topic he's talked about a lot. Many, many other areas. And finally, we need space to be safe and sustainable. That's absolutely critical, and it's something we have spent an enormous amount of time on over the last couple of years. If you followed what we have been doing at the Department of Commerce, we're in the process of transitioning notifications from the Department of Defense to the Department of Commerce for private sector and international space operators. And we're trying to do that with a view of two different aspects. One is to make the publicly available information more precise, more timely, even more persistent to support the space missions that I quickly reviewed a couple of minutes ago, but also to do it heavily leveraging the private sector. The space environment is changing at such a quick rate that we're going to have to leverage commercial capabilities to keep up at speed with the problem as it is also changing. And so a lot of our efforts have been focused on space safety and sustainability. You may have heard we are working on something called an open architecture data repository, if you will, a cloud-based platform. We will bring in a variety of data sets, both government and commercial, including the commercial capabilities of our allies, make sense of them, with modern analytic tools, visualization techniques, et cetera, et cetera, et cetera. But we're also working with our other government partners on what I'll call establishing new rules of the road for space. And those include international norms that we're working with the State Department and many of the European countries and countries from around the world, UN COPUOS activities, et cetera, but also leveraging industry standards and best practices. And that's something we have a unique role in doing in the United States, making sure that we are very tightly coupled to industry. That's very important in such a fast-moving industry because the technology will quickly outpace most policy development. And so we want to make sure that we're incorporating those best practices into what we're doing. So in short, what I'll say is that, you know, as I said at the start, we're very excited about the space economy from the U.S. perspective. We do see commercial activities being the mainstay of activities in space for the foreseeable future. And we think that's a very exciting development because it's going to allow us to explore the heavens at a much more efficient and perhaps faster rate. But it's also going to create wholly new capabilities that are going to affect our lives here on Earth. And so on that note, I'll stop, and I'll certainly look forward to the rest of the presentations. And thank you for having me today.
Thank you, Mr. O'Connell, for this very rich and insightful speech.
Thank you.
And you can disconnect. We can have a little pause, and in 2 minutes, we'll meet the next speaker.
Okay. All right, Jeff. Nice to see you briefly.
Good to see you. Take care, Kevin.
Okay, the next speaker is already here. I can see him. And since we are almost there, maybe we can start a bit slowly in order to catch also other people maybe coming a little bit later. But the next speaker is Jeff Manber, who is the founder and CEO of Nanoracks.
Buongiorno. It's nice to be here today, even in this limited capacity. And I want to say a special hello to my good friend Roberto Battiston. And I hope, Roberto, that we will be having some coffee together in 2021. What I'd like to do today is talk about the 3 pillars of activities that are taking place at Nanoracks. As many of you may know, Nanoracks is today the largest commercial user of the International Space Station. And we work on behalf of customers in over 30 countries, as well as for our own growing base of research and activities. And before I begin on the 3 pillars, let me say that I also speak to you today at a very exciting moment for Nanoracks, for the entire team. And that is a few days ago, our Bishop airlock arrived successfully at the space station on SpaceX 21. And we expect later next week to have the installation and the first checking out of the capabilities. But the Bishop airlock is representative of one of our pillars, which is the greater use of the International Space Station in a commercial manner. And the airlock is a commercial project, self-funded by Nanoracks, and working with our partners both in the States and in Italy, of course, with Thales Alenia Space and our friends at the Italian Space Agency, CASIC. And there's no better example of international cooperation in LEO than the Bishop airlock. And the fact that it's so international, and today it's at the International Space Station, is a very proud moment for all of us in the company. And why did we do the airlock? Why did a company choose to self-fund a piece of hardware on the government-owned space station? And that is because we saw inefficiencies. We love and appreciate very much the airlock there currently through JAXA, the Japanese Space Agency. But we saw a market need, a utilization need to have an airlock that would be bigger, 5 times bigger, and run by a commercial company with what we hope will be commercial efficiencies. And so that's just a perfect example as we look to the future, companies like Nanoracks and others must contribute to the ecosystem, not just in low Earth orbit, but also as we move on to the moon and one day to Mars. So one of the pillars at Nanoracks is the increasing utilization of the International Space Station and the Bishop airlock, the largest private real estate on the station that will be used on a daily basis, is the first, is the best example of that. And we have 2 other pillars at Nanoracks now that we're focused on. The first is, for 10 years, Nanoracks has proudly worked on the station, mostly on behalf of our customers. These customers range from biopharmaceutical to satellite deployment, Nanoracks has deployed close to 300 CubeSats from the space station for companies like Spire and Planet and GomSpace and so many others, as well as European Union and NASA. And so we've worked on behalf of customers, and we're very pleased as to how we've contributed to the growing use in low Earth orbit. But I wanted to take the company to a new level. And about 2 years ago, we began to look at where we could be the customer, where the Nanoracks hardware could work on behalf of services intended for another part of Nanoracks. And I'm very proud to say that two weeks ago, we announced the Starlab research project in Abu Dhabi in the Emirates. Our first partner is the Abu Dhabi Investment Office, AVIO. And this is a 5-year plan to use the harsh environment of space to produce microbes, bacteria, seeds that if they can survive and be created in the harsh environment of space, they may well be candidates to help green the Earth's deserts and help mitigate some of the horrific effects of climate change and climate migration. In other words, what we're doing here at Nanoracks is we're taking our unique access to space on the space station, on other platforms, and we're saying we want to drive ourselves and devote our resources with new partners to using space to help on some of the biggest problems we have here on Earth. With the innovative ag tech or space farming project, we see not only the market on the Earth, but of course we also see the market to sustain explorers as they move on to space with orbital greenhouses and the greenhouse on the moon. So this is a very exciting development for Nanoracks. Within 2 years, we will have close to a dozen researchers employed by Nanoracks who are working full-time in space research, in agricultural innovation, and not just in the biomass, but also in the technology needed to create the greenhouses in space. And that will contribute as well to vertical farming on the Earth. So that's our first 2 pillars at Nanoracks. The first being greater utilization of the International Space Station, and the second where more and more we are the customer and we are driving the utilization of the platforms. And so the third pillar is pretty logical, and that is as we look beyond the International Space Station. The International Space Station is a marvelous technological creation, probably the greatest technical feat of the last century, but it is aging. And we all know on this call, on this event, that 20 years is a long time, and it's we're beginning to see some of the aging consequences in the hardware on the space station already today. So at Nanoracks, we also are looking at what innovations can we contribute to that allow for cost efficiencies and private space stations. And one of the core areas we are focused on is the reuse of the upper stage of launch vehicles. Can we take an empty fuel tank that's in space and reuse it as a commercial space station? The answer is yes, with technology, robotics, autonomous software, and other advances. The answer is yes, one can. And we are now setting up a new program at Nanoracks to work both domestically in the States and internationally with partners in Europe and Asia on how do we repurpose upper stages so that as we look out to the rest of this decade, what we see is not one single or 2 single government-owned space stations. Instead, we see multiple space stations, each one devoted to a single market. So we'll have the automated space stations for research, manufacture. We'll have space stations, platforms for tourism. We'll have space stations for professional astronauts. I'm amazed that many people feel that still we can have a sustainable market in space tourism on board the International Space Station as it's currently configured. If you're a honeymoon couple, you don't want to be next to 5 government researchers. So the solution is simple. Well, it's not simple, but the solution is obvious. We need private space stations, each one devoted to its own share of the market, and Nanoracks hopes to contribute to that. So in summation, let me say that I'm optimistic that the commercialization of LEO, low Earth orbit, will continue. We're on the cusp of hitting some critical mass in the ecosystem. I believe that if I may speak about domestic politics, I believe the new administration here in the United States will be more open towards international partnerships, both on a civil and on a commercial basis. And so I'm comfortable that we will have greater momentum to have alliances and partners on an international basis. And my only fear, my only concern that I'll sort of leave you with today is that, you know, I haven't been convinced in the last 2 years that NASA can devote the resources necessary for us in America to return to the moon and to ensure the momentum continues in low Earth orbit. So what I'm looking for in the new administration is that we have a lot of big problems around the world today. We have the economy, we have the COVID. Those are huge problems we have to tackle. And at the same time, we need agencies like NASA and all the space agencies of the world to be able to also confront multiple problems at the same time. And that would be, how do we return to the, for Americans, how do we return to the moon? How do we build up the low Earth orbit infrastructure? And how do we use the space agency and all space agencies to help us solve the problems here on Earth? Of course, the biggest one that we can solve from space being climate change. So with that, I'll leave it there and say I miss all my friends in Europe. And let's hope that in 2021 we can get together in person. So thank you very much.
Okay, thank you, Jeff. Member, do you have maybe a video too?
Do you have the video? I don't have it. Do you have it?
I think not. So it's probably possible to stop here. And
I'll say go on YouTube, everybody, and take a look at the Bishop airlock. It's a beautiful video, if you haven't seen it, of it leaving the SpaceX and heading for the and heading for the station. So thank you for that. Thank you.
I keep you online because we have the video. So maybe you can comment on that. So it's going to go. Please.
So this was a very proud moment for us at Nanoracks. There you see the Bishop airlock as it's in the Dragon, moving away from the SpaceX vehicle, the Falcon, and now heading for the space station. So you can't imagine how happy all of us at Nanoracks were when we finally saw this moment. So that's it. You can end the video there if you want, but it's a wonderful example of public-private partnership between American company, Italian company, NASA, ASI, and the European Space Agency. So with that, thank you.
Thank you very much for this very interesting speech and for these glimpses of future that you gave us. And you can disconnect, and then we'll see with the rest of the people in a few minutes for the next speaker. Welcome back. We are ready now for our last speaker with Stephan Recchi, Executive Director of GenSpace, who is defined as a universal network of ecosystem for astropreneurs. Mr. Recchi, are you there? You can, the floor is yours.
Great, thank you very much. I'm excited to be batting cleanup behind an amazing group of speakers, Kevin, and especially after Jeff. What I wanted to do is just quickly go through investing in space, and I'll call it reaching for the stars. So my name is Stephan. I'm the executive director of Gen Space. I'll go through a quick introduction, talk about the impact of space, investment opportunities in space, and then why invest in space. As we saw, and as we know, space is very cool. Recently, this is a picture of inside the SpaceX Dragon module. It's a pretty Crew Dragon. It's pretty cool. I mean, it's touchscreen. Everything's exciting. The uniforms, the technology behind it. Jeff just mentioned, and super excited. This week, we sent up the Bishop ISS airlock, giving even more opportunities for astronauts to do investigations and access to space. This week also was key. Starship reusable space transport was tested, and really cool videos. Google that. And then also yesterday, Artemis returning to the moon soon. NASA put together the candidate pool for 18 folks. So we're going to have folks on the moon within the next couple of years, men and women. So quickly, my portfolio highlights: investor in Worldview, working with space stratospheric economies, Nanoracks, space laboratories, and all the cool things that Jeff just mentioned, and Space Nation, where we're looking at giving experiences to people on Earth that are space-based or space-themed to figure out how we can be better citizens on Earth. I'm the executive director of Gen Space, and Gen Space is a global network of ecosystems that really helps bring together all the necessary pieces for people to be astropreneurs, namely entrepreneurs to do business in space. We connect folks, we advise folks, and most importantly, we inspire. We inspire the next generation of future workforce for opportunities in space. When it comes to space, looking down at the Earth, you only see a global economy. So the opportunity is focusing on entrepreneurial things to look at a single market versus segments. Every resource that we've had on Earth exists in abundance in space. Kevin mentioned that as well. And because there are no borders in space, there really is a big need and focus for international cooperation. The UN put together the Sustainable Development Goals. Just to highlight a couple, hunger can be addressed from space to look at optimization of whether it's crops or livestock, productivity from Earth observation, and figuring out what land is suitable for that. Health, there's so much stuff being done with remote healthcare and disease monitoring, whether it's from space or technology that's been used in space. Clean water, whether you're looking at the quality of the water measuring, and also weather forecasting. Today, this is just a short list of things that were built in space that we're working towards making the better of the world. So from medical, just things, simple things like ear thermometers, baby formula, LED lighting, and on a daily basis, we all touch space, whether it's through global positioning systems or figuring out what the weather is going to be like, or satellite or broadband communications. When it comes to investments in space, I have a couple of slides here breaking down. Today, you can invest in companies that are doing business in Earth observation, GPS, whether it's spin-offs that were done in space that are looking at solving problems on Earth. Microgravity research, Jeff mentioned that. There's a lot of research that's been done over the past 20 years on the ISS, and there's technologies that are being driven from that. Soon, they'll be doing in-space manufacturing, but we do have 3D printers up in space. Constellations are being built for global communications and global internet access, and we're coming up with faster technology to do suborbital transportation. Space tourism is coming up, but the big things in terms of orbital debris, space mining, all the different aspects of that. Down the road, looking at supporting space migration, figuring out what are the benefits for low gravity health, and then figuring out how to really make it so that you can industrialize space in a mainstream fashion. Kevin mentioned the space investments have been growing year to year. 2019, we had almost $6 billion invested in space, ranging from angels to venture capitals. And here's just a quick breakdown of the different portions that the investments have been coming from. When it comes to doing business in space, it's getting cheaper, easier, faster through reusability. Space agencies such as NASA and ESA are putting together organizations to help commercialize space, and access to space data is getting cheaper and more prevalent. So ESA has an example for Copernicus on how you can use their data from their space now is open to anyone. Elementary schools have flown and built CubeSats. Middle schools have access to space. I was involved with a school in Golden, Colorado that sent a project up to the ISS in 2017. Accelerators have space cohorts, and pitch competitions have become global. I'm excited that Spacecom's Entrepreneurial Summit and Challenge has been growing, and this year, due to the global aspect of it, it's going to be even bigger and better, the largest accelerator or space competition in the world. Why invest in space? The angels are there, the VCs are there, the space agencies are providing grants, and it's getting more and more traditional in terms of the investment chain. When it comes to why people want to invest in space, the motivations, because you have the ability to get in early on these high-risk ventures, the risks are getting mitigated so you can get higher returns. We're finding folks that are super excited about funding the future, getting access to faster-paced innovation, being part of something cool, as I started with this presentation, making science fiction a reality. And then last but not least is impact. So being able to invest in things that are impactful to society. Historically, it was only for billionaires, but now there's opportunities for everyone to get involved. The business economics are becoming more obtainable, cheaper access to space, and you don't have to be a rocket scientist to understand what you're investing in. There are business models that are explainable, replicable, and there are also career opportunities for folks outside of the technical answer. So in short, space can now offer answers to these questions. Does anyone want it? You can actually do an analysis in your diligence. Are there a lot of people that want that? You can actually start to quantify your market sizes. And can you find those people? We can actually start looking at entrepreneurs that can put together business models that are understandable. Thanks a lot. I know that I went through this relatively quickly. Please feel free to ask questions, email me, and I look forward to the opportunity of answering them. It's a real big honor to be presenting at this conference, and I look forward to being involved and helping in any manner possible.
Okay, thank you. Thank you, Stephan, for this nice presentation. The connection was good. It was better maybe with the US than in the beginning. But now I think this is the best conclusion for this session. And I thank again all the speakers. So goodbye and see you as soon as possible. Bye.
Thank you.